We're going to look at for loops today. For loops are another control structure. We looked at the while loops before. For loops a little different. It allows you to set more strict guidelines for how long it's going to run. So we'll just look at one really quickly here. I got a document open, ready to go here. So we'll just do for x in range 10, print x. This will give us a chance to really just quickly see what it's going to do. So hit run on that, and you see that it prints from 0 to 9, not including 10. So it goes from the first number being 0 up until whatever number you're putting in, but when it hits that number, it breaks. So it checks the condition every time, just like the while loop. It checks the condition, so when x gets to 10, it quits, it doesn't print. If we want to print the normal counting numbers, like a little kid would count if you asked them to count to 10, we can tell it the starting condition 1, then a comma, then 11, and so it'll print starting at 1, going to 10, and not printing 11. So that is the basics of the for loop. It'll run through as many times as you want it to. There are lots of different uses for this. One way we can use it is to move through a list or through characters in a string. So I'll just put a so I'm just going to put a quick little string there. If you've never seen that one before, you haven't watched My Fair Lady, you're not missing much. I'm sure someone's going to be mad at me for saying that. But, so I just put this quick saying, the rain in Spain stays mainly on the plain. And so if I went for n in saying, so it's going to go for n for everything in saying, print n. So we'll see here, it will go through, and every time it prints one of the letters. So we can move ourselves through a string that way. Useful if we're going to be counting letters or counting spaces. We could say, for n in saying, if n equals space. So if n's a blank, space. We'll make a little counter here. So, word count equals word count plus 1. And then at the end we will print word counts. So now we have a quick little program here. It's going to go through, and every time it sees a space, it's going to add a word. And since we don't have a space before the first word, we're going to start our word count at 1 for the first word. So if we run this, now it gives me 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I got it right. So there's a quick way we could use this just to do a word count. We can work with lists. So, I'll make a list. To make a list, you start with a square bracket, then you put your items. They can be numbers, words, whatever we want. They can actually be other lists as well. So we got some people, some names, students' names. So now I'm just going to change my statement for element. And whatever, I'm just saying L for elements, but that it doesn't mean anything. I can put any variable I want for L in print length of the element. We'll do that. So L ling and L, so that's a string. It'll tell me the length of the string that's there. So Ben is 3 letters long, Jim's 3, Sue's 3, Fred's 4, Parker is 6. So that's another way we can just go through and iterate through elements in a list. So we haven't really done anything interesting with this yet, but what I've done here is I took a previous program that we used. It was just calculating, it was using the compounding interest formula to calculate the value of an investment. And at the end of it, we just calculated and printed out the estimate. So what I did is I changed this up a little bit. So this program has an information function. The information function gathers the information about the investment. The principal, the interest rate, the length of a compounding period in months, and then how many months the investment's been there. So for that, we gather all those values. Then it has a calculate where it takes those values and figures out the amount of the investment at the end of that term. Then it has an output function where instead of just calculating the amount at the end, it goes through each month from the first month until the last month that we inputted. So for the months in the range 1 to the total amount of time plus 1, because remember that the for loop won't print the last one, it'll print up to the last one. So we got to go one more than we want to print. It's going to print out the word month and then what month it is, and then it's going to use the calculate function to print the value at the end of that month. So if I run this program now, principal 5,000, interest rate, we'll give them a 5% interest rate, compounding once a month for 24 months. This is an investment you'd never get right now, but here we go. Now we have a print the way we want it to be. So here we go. Put in our information that our investment at the end is going to be worth $5,024.71. And then it goes through each month at the end of month 1, at the end of month 2, 3, 4, 5, and all the way till month 24, which equals the final amount. So that's what the for loop's doing here. The for loop is going through every month individually because that's what I told it to. So that's one practical application of a for loop. Another practical application of the for loop would be to print out all the prime numbers that you might want. So that's what this program actually does. It takes in a number, whatever the number you want to get up to. And if the number is greater than or equal to 2, we're going to start a list with 2 in it because we know that 2 is a prime number, so we're not even going to worry about checking it. Then for numbers in the range from 3 to whatever number our user inputs, and we're only going to do the odd numbers. We're going to go up by 2, so we're going to go 3, 5, 7, 9, so on, because all the even numbers aren't prime numbers. So then we check if all the numbers, if all of the times we take that number and divide it by every single number from 3 to the square root of that number. So if we don't get a remainder of 0 any time in that situation, that's the definition of a prime number, because the remainder of 0 means it's divisible by that number. So, as I said, we can do it quickly here. I did 1,000. Let's do another one, 10,000. Big lists here. And if my number's going to be 10,000, and here we go. I get a list of prime numbers, all the prime numbers up to 10,000, sorry. And we do this by using a for loop. So for loops are very useful in running repetitive tasks. It's that's how we can use for loops for doing an iterative task. So iterative means that you just have to keep doing it over the same pattern. So we can iterate through lists by going each element. We can iterate through strings by going each character. And we can iterate through ranges of numbers. One task that's also another task related to the prime number task, and you can probably use the prime number program to sort of give you an idea how to do it. I want you to write a program that when the user gives you a number, you will print out all of the factors of that number. That's going to be your task.